So, welcome also from my side. Most of the introduction has already been done. So, the subtitle basically gives you the overall idea of what this presentation is about: how to add experimental post-quantum crypto into OpenSSL. This is work that has been going on for now, I would say about, well, it depends on when you start, 10 years based on the OQS project, 5 years on the oqsprovider project. So what I'll be doing is, I'll be giving a bit of the background of the project, design principles, the history, how everything worked, what is creating all these lessons that at least I learned and maybe some of you may be finding interesting and that I would really like to get across to you, and giving you a little bit of an outlook of what potential futures we see based on the work that has been done. So to get started, OQS is the Open Quantum Safe project. It's an open source project started in 2015 by the University of Waterloo. It's basically a collection of post-quantum crypto algorithms in evaluation. That was part of the NIST competition in which NIST wanted to find algorithms that are safe against quantum computers. What is important for this presentation or for the technology in general is everything is collected into C APIs. It's a C language library with specific APIs for signatures and key encryption management algorithms, KEMs. The other thing that's really important to notice is that what OQS wanted to do, and also what I try to do in oqsprovider, is to create a system that does not pick winners before some standards bodies pick them. So everything should be as generic, as open as possible for any kinds of algorithms, because you never know which algorithm may fall away during the competition because of some security problems. What OQS also does, and what I started with, is integrations into various applications, various libraries. And the goal there was simply to enable people to use those post-quantum algorithms. They have completely different properties than classic algorithms. They may be longer, they may be slower, they may be just different. And the way to see really which algorithm works best in which condition is, well, to use it, to make it usable. So we wanted to do these integrations, and of course we choose packages that are used very, very widely, and obviously things like OpenSSH, OpenSSL were the clear candidates. This work started before I joined the project with a fork that Microsoft Research created, Christian Paquin in particular. He basically plugged in the then current set of PQ algorithms into a fork of OpenSSL. And he also added features for not just supporting TLS operations, but also hybrid operations, which basically is a blend of PQ and classic cryptography. Problem was, at the time then, that I slowly joined the project, and I have to admit I'm a very lazy guy. So I didn't like always following the latest version of OpenSSL. Everything was based on version 1.1.1 of OpenSSL. And whenever something changed in OpenSSL, of course, we needed to update our fork. We needed to update all the integrations. And that was not fun. In addition, some changes to the algorithms, to the PQ algorithms happened, so also they needed to be changed. So I, at the point of time, me mostly doing that work, was squeezed on two sides. Top side, OpenSSL changed, bottom side, the algorithms changed. So not a lot of fun, very tedious work. But fortunately, somebody came to the great idea of introducing in OpenSSL 3.0 the concept of providers. Very basically, what is a provider? It's the capability to extend the core cryptographic capabilities of OpenSSL by defined APIs. So people who know what they do for ciphers, for digest, for signatures, for KEMs, for random number generators, all those different components essential to make OpenSSL tick correctly and securely are able to be extended by the provider concept. What was important for us at the time was that everything worked already very nicely for KEMs. So the introduction of PQ KEMs was pretty straightforward, and we used that. The other element of importance is signature integration and, of course, key management. Everything around creation of keys, triggering the creation of keys, storing, persisting them. All of that done by the provider API. What you can also do in OpenSSL providers is you can either use them statically, linked into an executable, so that all the new capabilities are already built into the system, or you just have a shared library. You simply plug in the new provider with the new capabilities, in our case, post-quantum crypto, and OpenSSL all of a sudden picks up all of those new capabilities. Very nice feature. So you have a standard OpenSSL installation, and you can just give it new features by way of this extension mechanism. Also important to know internally, possibly most of you already know it, OpenSSL uses this concept internally to implement its own crypto. Things like the default crypto, everything that you always need, FIPS crypto, certified, particularly hardened crypto variants, but also, for example, legacy crypto, algorithms that are not really recommendable to be used, but that some people still use in some old legacy systems. Also part of the provider ecosystem, I would say. Load legacy crypto, and OpenSSL also supports that. So what are the design principles at the time that we started this work? That was around about 2021. One I already mentioned, choose no winners. We wanted to have a system that allows anyone to work with any PQ algorithm to try them out. The goal was not just to use liboqs, but also to have the ability to easily add new algorithms. Not just new versions, but also completely new algorithms. Second thing is, we wanted to be the enabler of these experiments using OpenSSL in all OpenSSL versions, starting with 3.0. So the goal was, as the OpenSSL feature set for anything, for any crypto, for any security capability, or for any feature set like signatures, pluggable signatures as an example, evolves, the OQS provider should automatically adapt to it. So the idea is, take one shared library, plug it into any OpenSSL deployment larger than 3.0, and it should work and adapt to those capabilities. Next one, easy to maintain and use. Again, I already mentioned I'm a lazy person. I do most of the work. I think right now something like 85 to 90% of the code still is mine. I'm maintaining it, and I want an easy life. I want the system to be able to adapt as much as possible, as much automation as you can possibly have in the system. And the goal also was, I did not want to duplicate anything else that is out there in the free and open source world. So the goal really is use what's there, generate as much code as possible. What we also did is we started using algorithm names as they became available and kept them supported, even across algorithm releases. There the goal was that people who are integrating our system in a way to show that something works, like for example using curl, they could use curl with Kyber as a KEM and always use the name Kyber in their applications, in their configurations, even though underneath liboqs or we changed the code every now and then. Our focus really was on the shared lib deployment. One of the important things there is that OQS provider does not depend on internal capabilities of OpenSSL. It could, like for certain features like constant time properties, but we didn't want to do that because exactly we want to have OQS provider work in all kinds of different installations of OpenSSL, independent of which particular internal crypto capabilities are there. So, for those of you who, like me, are feeling a little bit sad of only seeing text, now the graphic slide. First of all, you start on the top with applications that are based on OpenSSL. OpenSSL, what is OpenSSL? For me, everybody says it's the library, OpenSSL library. It's two libraries actually, libcrypto for the crypto capabilities and libSSL for TLS. oqsprovider, in this particular case, is providing certain features to OpenSSL exactly to enable PQ crypto. Underneath, it's using liboqs as the actual container for these implementations of the various crypto algorithms. oqsprovider makes it available to libcrypto via the provider API and the TLS capabilities via the provider capabilities. Two terms you may not need to know. If you are into provider development or use of the system, you may recognize them. That's how we do it. Then we have two elements with an oqsprovider. One is the pure PQ logic. So if you just want to use a standard PQ algorithm like MLChem, for example, that's where the code is residing. libcrypto wants MLChem goes via oqsprovider to the pure PQ logic into liboqs via the oqs API that I mentioned at the start. We also have built into oqsprovider hybrid logic, which allows us to run at the same time classic crypto, things like RSA or elliptic curves, as well as PQ, for situations in which you don't yet quite trust PQ and still want to use classic crypto. There, we are using libcrypto of OpenSSL. And to make matters even more interesting, liboqs also uses libcrypto, for example, for randomness generation. And this picture shows you basically the most interesting thing, or the reason why I'm actually here and giving this presentation. This is pretty strange or unique, if you allow that statement. In oqsprovider, we are providing capabilities to OpenSSL, but also use them. What that means is we are a consumer and producer to OpenSSL. I have to work with OpenSSL, but also provided certain features. So that is creating a setup which is always sometimes challenging, but I'll tell you about our experience, how that got resolved very nicely. So history, very quick rundown. 2021, everything started only Linux-based initially. Everything was done at the time, from my knowledge, mirroring the presentation by Matt in the morning, by something that I knew at the time, how to use OpenSSL. Within the OpenSSL code base, there was a little corner for providers. I added the code there. I had a few questions and got into contact with someone in OpenSSL, Richard Levitt. He was really very, very helpful, answering all kinds of questions, and was the one who helped me extract everything out of the original OpenSSL codebase into its own standalone project. Then also someone else came online, Basil Hess from IBM, integrating or adding hybrid CAM capabilities into the system. 2022 was the year of OQS or PQ signature integration. It wasn't quite as simple as just adding another API. It also required a few changes to OpenSSL itself. By the time, I fortunately knew quite a few people in OpenSSL, and they were all ultra helpful, getting my questions answered, getting my PRs accepted. Well, some of them also got rejected, but ultimately, we had the ability to really plug new signature algorithms, and we started with PQ signature. In the year also, we completed hybrid signature support and all of the mechanisms around persisting signature elements, which is essentially if you want to, for example, generate certificates and store them. 23, that was basically the year in which we fanned out to more platforms. More people helped work on platforms that I'm not using, like Windows or Mac. People started supporting static builds because they wanted to hide everything in one executable. So that was a capability added there. And then quite a bit of interesting work happened when the IETF hackathon project started for certificate interoperability. They gave us quite a few ideas in terms of how to make the system more experimentation friendly to allow it to be used for comparing various algorithms to each other. 24, There was another feature added, composite signature algorithms. It's a different type of hybrids, different spec that was done by Entrust Felipe Ventura. And also the OQS project joined, found enthusiastic adopters in the Linux Foundation organization that have a slightly different perspective on how open source is done, at least from my experience, but I'll cover that a bit later. 25, some new algorithms got added, but courtesy of most of the automation, that was pretty simple, straightforward to be done. Actually, I wasn't even participating in the project at that time. But also there was already a reduction in the feature set because, well, not too many people participated in the project at that time. So where do we stand right now? oqsprovider supports 152 post-quantum algorithms or hybrid variants of that. That's definitely way more algorithms that are currently standardized, but that's showing what this project is about. It's about enabling experimentation with all kinds of different combinations. 4 TLS 1.3 KEM operations for anything around certificate generation, for anything around signature operations in TLS connection setup. All using standard OpenSSL interfaces. You don't see what's running underneath, which is nice. The only thing you change, of course, is the algorithm name if you want to use something else. Everything is driven from basically one configuration file in which you say which algorithms you want to use. And you can even specify which classic algorithms you want to combine them with if you are interested in experimenting with such hybrids. It is adapting to the OpenSSL 3 runtime, so whichever installation you have, it's working there pretty nicely. Works on many different variants, as I mentioned. Now, that's why this presentation is in this track, community, contributing. And also one of the things that I really want to get across to all of you, please help, please contribute. I want to share with you what I experienced in doing this project, what worked, what didn't work, or what anyone interested in contributing may want to consider. 1, reach out to the community. And the community is, in my opinion, basically anyone active on GitHub, for example. It does not only mean committers, it also means any contributor, anyone who may have an interest in a particular area or in a particular piece of the code base of OpenSSL. Reach out to them, ask questions, because this may be getting across as a little bit critical, but that's how software is. Some things may not be documented. They may not be documented fully. They may not work as intended. Some features may be missing, even though they are documented. Some features may be buggy. It's software. That happens in all software. In open source software, the special thing is everybody can see it. But the important thing is everybody can fix it. So that is basically the question. Don't just use it, help improve it. And in my particular case, being sandwiched between OpenSSL as a provider and a consumer, this was essential, really, to be able to get that done. So Tim suggested I give first a bad example, saying, okay, how do you want to be perceived as a contributor? How do you want to contribute? Option 1, you are an idiot. Your API does not work. Fix it. Well, as a maintainer, if somebody sends me such a message, I may not be immediately enticed to respond. I don't know why. Maybe you are. I'm not. So I prefer to take it around and say what does work, in my opinion. And, well, I can give various examples throughout the project, throughout the years, what did work. One is be cautious. Do assume that there are other alternative assumptions how the code has been developed, how it could be used. Just think some other explanations are possible before asking silly questions or nasty questions. Then try stuff out first. Don't just rely on the documentation. write some code, test it, try it, give it a go. If you're then sufficiently sure that the problem is not between here and there, you may want to write some comments. If you do, please explain all of your assumptions. What do you think how things should be working, in particular if something is not documented, so that other people can understand your thinking? And finally, we are talking about developing software. Please provide code examples. Nothing works as nicely as seeing code running into a problem, because then you can fix it. Or you can just understand the problem. So, that was on the more generic side of things. How should a good cooperation work? Anyone contributing to OQS? I would be happy if you were doing that. Anyone contributing to OpenSSL? I think the OpenSSL team will also appreciate that. So, looking back, OQS provider, the design concepts, in my opinion, everything worked nicely for a couple of years now. Adding new algorithms is trivial. Hybridization new algorithms works pretty nicely without too much interaction on our side. The one binary can be used in any install across different platforms. Very nice thing. Then something interesting happened. At the beginning of the year, many people, a little bit also myself, started integrating PQ into OpenSSL master, into the base system, because some of those algorithms got standardized. So we didn't choose the winner, but NIST did. So algorithms like MLChem, MLDSA, SLHDSA got standardized. And now, guess what happens if you are loading OQS provider into an installation that already has these algorithms loaded? They become disabled in OQS provider. And the core standardized production quality code of OpenSSL kicks in, which is pretty nice. Because all of those people coming to us and saying, hey, you research guys, or you test enablers, make this product code good now that I can bring it out to millions of customers. No, that's not the goal. OQS was about enabling research. We always said, don't use this code in production settings. Please use really well-developed code, well-reviewed code that comes from a very well-known origin if you want to do something productively. OQS provider still is being used in OpenSSL as an external test. For those of you who know OpenSSL, there is lots of tests, but also a section called external testing, which is software that is not necessarily maintained by the core OpenSSL team, but which does provide a certain functionality for OpenSSL, namely to stress test it in a certain sense. And in the case of OQS provider, I think no provider in the world except this one is providing as many algorithms in one go as OQS provider. No provider other than OQS is creating signatures way longer than anything that OpenSSL currently supports, or KEMs, whatever. It's really a stress test for the system. And as such, we try to keep it and maintain it, even if just for that purpose. One drawback is that OQS provider does not permit you to do per algorithm optimizations. So if you really want to use the nicest feature capability of, say, dilithium, this is not the way to do it. OQS provider really has lots of automation built in that allows you to use any libOQS algorithm, but not one in a particularly tweaked way. We intentionally didn't want that. We wanted to be able to use any algorithm just so that people can work with them and experiment with them. Third set of lessons. And I think Tim, everybody this morning made it very clear. Making people meet is key so that they understand each other, their way of thinking, their motivation. In this particular case, when the originally completely research-driven OKS project merged with Linux Foundation, which has a slightly higher slant to its commercialization. There was a clash of cultures, I would call it. So that is something that can be, in my opinion, resolved if you make people meet early. Just these two cultures to make them understand each other better. Examples like, how is a project meant to be used? One side says, well, we want to enable research by anyone, everywhere, with all kinds of algorithms, so that anyone who has an idea of a particular PQ algorithm should be able to use it. The other side says, nope, I need to have support, rock-solid support, to roll out a product. There are clashes in those goals that you may obviously see. How to treat contributors. I was very happy to see these stats this morning that also within OpenSSL there are, 30% contributors who are individuals, who are self-motivated, who want to make the world better, who want to contribute to OpenSSL, to contribute to the mission. And then there are corporate contributors who may also want to make the world better, but who are primarily motivated, possibly, by their paycheck, and who have to follow corporate strategies. Perfectly understandable. But there are some slight collisions of interest in those cases. Another one is, if you are integrating different contributor types, have a look at how large the two different communities are. In the case of Linux Foundation, it's a huge organization which is managing many hundreds of projects with hundreds of thousands of contributors and maintainers. OKS has about 2 or 3. Using the same mechanisms may not be a good idea. And well, this is a reminder of the past. That's also why I'm using this presentation format. Going back to the 80s, this is what I think open source is about. To trust the people who do the software, control them, check them, ideally between peers, but rein in the management by non-contributors. They can manage, for sure. They can hold the purse strings. They can define what the priorities are, but they should not change how code is written. That can go wrong in a big time. So, what are some of the challenges? Technically, where do we plug in OpenSSL-based support? We need, in oqsprovider, hashes, classic KEM crypto. We need random number generators. We need SHA-3 optimized code. And we use them in all kinds of different areas. We use it in liboqs, we use it in oqsprovider. Where to place it best for, say, extensibility? Question still for discussion. The the provider concept within OpenSSL contains, in my opinion, lots of boilerplate code, lots of macros. I think there is room for improvement. Or maybe yet another generator generically suited for generating provider code in general. Not just PQ provider code, but provider code. And the QBIP project from Nicola is, are you there somewhere? Thank you, is the perfect example. So please go to his presentation on Thursday, I guess. And then technically, for those of you who are into that, NITs, in my opinion, still are a problem, something possibly to be removed out of the system, out of at least any APIs to make things work easier. So, what is it that we would like to do in OKS, or what I would like to suggest OKS to be doing, of course. It's not just me. The goal is not to compete with anything that's really targeted towards commercial use. We want to be able to assist researchers making better reference code, making reference code that one can use, making reference code that possibly can be brought into productive use, use the right license terms, things like that, things like what we learned over the past 5 to 10 years. Technically, create another abstraction layer. Just again, for those of you who like pictures, just two different ways how to possibly structure the system. If you were just interested in creating a pure hybrid provider or an algorithm-specific provider. Reading at home, nothing really to be discussed now here. So I'd like to conclude with the very same statement that we heard in the morning. Contribute, please contribute. This project lives from many, many researchers able and willing to provide their crypto code, their PQ thoughts, some mathematicians writing code, but then not knowing exactly how do I bring this into the real world? How do I integrate this into an OpenSSL stack? Well, they shouldn't care about it. They should do good math. And the goal here, really here is to make this possible via oqsprovider. So my question or my wish is, please go to this website, go to GitHub and provide contributions. And even if it's just a question that makes us think, did we do something wrong? Is there something that can be contributed? And right now, we are looking at a kind of major redesign of the system, possibly changing some of the design assumptions. So anyone who has other thoughts than what you've seen here or anywhere else, please come up, please speak up. There is a virtual meeting also October 23rd for anyone that you may meet afterwards and that you may want to invite coming to this event. Please share this information, make people come and participate, and ultimately contribute. Thank you very much.
Hello. First, I want to thank you for this project. Well, the liboqs and oqsprovider project had the most responsive and supportive upstream I ever worked in, 12 from 10. Well, and without your project, it was basically impossible to get the results we get in the distributions Red Hat supportive, and in the post-quantum project we are involved with Nicola.
Thank you.
So thank you very much.
Thank you.
Well,
amazing.
I also would like to say that despite you several times repeat here and many times in various discussions that OQS project is not productive, not production ready. Yeah, the problem is that it's basically the only game in the town when you try to work with something not standard. So we used to rely on it in our crypto libraries, at least in GNU-TLS, don't remember about NSS. I'm sure that for some experimental stuff or corner cases that are not covered by OpenSSL upstream yet, we will rely also on oqsprovider. So this cat is sort of out of box. And again, thank you very much. It was a great effort, and I hope you will not drop it down. Thank you very much.
Thank you very, very much.
Amazing.
That's definitely motivating. Thanks.
And I think here was another hands up, another question. Yes, here in the middle.
Hi, I have a question that how to deal with the algorithm that finally proven insecure, such as the super-singular Argentine-based SIKE, and will they be deleted from the library?
Which algorithm?
Such as SIKE, which is super.
SIKE, yes. I think SIKE is already removed. I think we don't support it anymore.
So you will remove all the algorithm that finally insecure?
Yes. That already did happen. And with SIKE, I think that's gone.
Thank you.
Yes, one more.
So just adding on to the comment about the support not being production ready. Since the Linux Foundation has gotten involved, do you see that it's moving more towards secure coding practices, and so folks that do want to look at those implementations for production systems can have more confidence in the actual software engineering that's happening behind the scenes? Is there any?
It's difficult, I would say. I mean, one of the things that liboqs has been doing from the start is importing these reference implementations. Sure. So we are relying, two steps behind the scene, so to say, within liboqs, we are relying on these reference implementations. And these reference implementations are very often done by researchers that rely on papers, publish or perish. And once they can't publish anymore, they're not really that much into supporting that code anymore. And if we don't find another implementation which is more well supported, recently that has been done for MLChem, for example, from another code base. So we could switch from reference code to another code base. But that's the key question. Where do we get, or where does OQS get its code from?
Okay.
And until we have a very good, at least until I have a very good confidence that I can rely on those people providing us that code, I would not change the statement, beware what you do.
So essentially there's no efforts inside of OQS to vet those implementations to kind of increase the...
There is some effort. I mean, part of this PQCA alliance, and tomorrow there will be a presentation by Douglas DeBeeler, who has been founding the OQS project. He will be giving more details on that. Within this PQCA alliance, there is a sister project, PQCP, and they are exactly trying to do that verifiable variants of the algorithms that are then geared for productive use.
Awesome. Thank you for the awesome talk and the awesome library.
Thank you.
Thank you, Michael. It's amazing. And thank you for your big contribution. And I hope the message for everybody will be contribute, contribute, contribute. Thank you. Big applause. Michael Baentsch.
Thanks.